In this section, we're going to be learning about antiderivatives, which is just basically the backward process of finding a derivative. So as it states, a function f, so they're using a capital F here, which is going to be different from your lowercase. So a function f, this uppercase f, is an antiderivative of your lowercase function f if you were to take the derivative of the capital F and it equal the little f, those two functions being the same. So basically, like I said, what we're doing is working backward here. So you're thinking of your lowercase f of x as being the original function, okay? So if you were to take the derivative of the antiderivative, then you would get your original function back. Like, so if you start out with your antiderivative, take its derivative, then you would get the original function back, okay? So here is something you need to think about, though, whenever you're doing an antiderivative. If you're asked to find the derivative with respect to x of some function and you get 3x squared, what would this function have to be? So what function can you take the derivative of and you get 3x squared? Okay, so a couple functions that I have written down here. So for instance, I have x cubed plus 6. So if I were to take the derivative of this, would I get this? And of course, I've got the question there, is this true? And actually, that it would be yes. But what about this one, the x cubed minus 9? If I take the derivative of x cubed minus 9, would I get 3x squared? And your answer would be yes again, okay? So, if you notice, I've got two different functions that have produced the same derivative, okay? So, if I were to find the antiderivative of this, then I should be able to get this back, okay? So you've got to keep in mind that by having a constant added or subtracted actually doesn't change the derivative, because when you take your derivative of your constant, that just gives you 0, okay? So as I've stated here, so capital F of x equal to just x cubed, or capital F of x equal to x cubed plus 6, or x cubed minus 9, are all antiderivatives of the function 3x squared, okay? So as I said, if we have this function, these are all would be referred to as antiderivatives. Okay, in just a minute, just again, keep in mind that having the plus 6 minus 9 didn't make any difference when we had our derivative over here. Okay, now just some notation here, what things are. All right, this is what's called your integral sign, and that's what's going to tell you that you're being asked to find an antiderivative, okay? So that's called your integral sign. This is just going to be your function, which is referred to as your integrand. And having dx on here, this just tells you that you're doing your integration, like in this case, with respect to x. So that just means that your function here, your integrand, would be in terms of x, and that's the variable that you're doing the integration with respect to. We've talked about that with derivatives. Okay, so once you go through this process of finding the or going through this integral process or integration, and I'll talk about those words in just a second, and this is what you come up with. This is again what's called your antiderivative, okay? Now you notice it's got the plus c. That goes back to what I was talking about a while ago with the plus 6 and the minus 9. Even though I had different constants added or subtracted, I still ended up with the same derivative. So when we're working backward and, we're trying to figure out, what function gave us that particular derivative, there's no way for us to know if there even was a number added or subtracted, or even what it was, okay? So we just always have to say plus c, meaning that it's just some constant. It could be the plus 6, it could be the, the minus 9. All right, so some wording here, or words that you'll hear used. Of course, you've already heard me use antiderivative. That can also be referred to as finding an indefinite integral. You actually won't learn a whole lot about indefinite and definite until you get a little bit further in chapter 4, which won't happen until Cal 2. But this process that you're going through is referred to as antidifferentiation. Of course, you're accustomed to the word differentiation, but as I said, this is basically just the reverse process. It's the easy way of thinking of it. So therefore, it's called anti-differentiation, or it's also referred to as integration. Okay, so of course, using the word integration ties back to the fact, this has got similar root word here. In fact, this is called your integral sign, and this is called your integrand, and the process is called integration. Okay, now there's a list of rules, just like you had a list of rules with finding derivatives. So you need to write these down. Okay, so you'll just need to pause the video and just write these down, but I'm going to talk about them just a little bit. So if you are asked to integrate 0 with respect to x, then that's going to be just a constant, okay? Now remember, this is the reverse. So if I said, okay, what is the derivative of a constant? The derivative of the constant is 0. Like I said, we're working backward this time, okay? Now, k is a number, and we're representing some number here besides 0, because, of course, obviously this is 0. So if you are asked to integrate, let's just say 2. You're asked to integrate 2 dx, then that means this would be 2x plus c. But if you take the derivative of 2x, remember the derivative of 2x would just be 2, or whatever k happens to be representing, okay? Now the third rule that you have here, you have some number times a function. Just like with a derivative, when you have a constant multiple, you can just pull that constant multiple out front. So like if you have 5 times a function, you can pull the 5 out front and then just concentrate on integrating whatever the function is. Okay, this rule is just showing you that similar to derivative, if you're asked to integrate a sum or a difference, then you are allowed to split it up and just integrate those terms individually, just like I said, you do with finding a derivative. Okay, now this is your power rule, so you got to keep in mind, again, this is reverse of your power rule with your derivative, which is to bring the power to the front, and you remember you decrease your power by 1. So what's going to happen here is you're going to increase your power by 1. So like if you have x to the 4th power, then that means your numerator is going to actually end up being x to the 5th power, because you're going to increase your power by 1. But after you increase that power by 1, so the example I was using, we now have a 5th power, you then have to divide by that. So if this is a 4, then this would be a 5, and this would be a 5. So you increase your power by 1 and then divide by that power. And then these are just the, obviously some of the trig functions. Okay, so this is just a matter of you've got to go down through here and just memorize those. Okay, of course, they're similar. If you look back at your derivative rules, you'll see similarity. And actually, I've got the, let me just open this up. And you don't have to write down this side. This is the derivative rules. But like for instance, if you compare these two, of course, this is the ones with the negative. And see here, when you take the derivative of tangent, you get secant squared. Therefore, when you integrate secant squared, you get tangent. On the derivative side, the derivative of secant is secant tangent. Therefore, if you're integrating secant tangent, you just get secant. So these are strictly just the reverse of these, okay?